will people online be able to see? Do I have to stand someplace specific so they can see me?
Yeah, just in front.
If I stand here, if I stand in this area,
Yeah. I hope that
there's a way to hide non-video participants over here.
Non-video participants?
Yeah, people who this pictures. Okay, anyway, never mind. We've lost time.
Okay.
Let's get to this.
Okay. Just.
This is your model.
So you can change with this mouse. It's not it doesn't run anyway.
Oh, this doesn't run anyway.
Yeah, I don't know why. Can you? Everybody can. Vous nous entendez? Est-ce que vous nous entendez? Quelqu'un peut me dire, Mademoiselle Béraud, par exemple,
oui,
ou Monsieur.
Oui, on vous entend.
Vous nous entendez?
Oui.
Ok. Très bien, la conférence va commencer. J'ai eu un petit problème avec mon ordinateur personnel, j'ai dû switcher. Donc, merci de votre patience. On va pouvoir commencer. Ok.
All right, so we had so much fun. That was good. But I'm now little 20 minutes behind starting. I will not go fast. I may skip a few things in between, because if I go fast, you will miss it all. I would rather go at a speed. Were you able to follow me in the last 15 minutes? Yes. Fantastic. So one of you can still win this at the end of the lecture, because I have one extra that I can give without having to take it back to you. So the first person to ask me a good question, not any question, good question, will get this. All right, let's start. We are in the middle of the revolution called 4.0, Industry 4.0. Have you heard the term Industry 4.0? Fantastic. Just a little bit, looks like. I will clarify a little more as to what that is. When we bring the Industry 4.0 technologies into the domain of inspections, assuring safety of airplanes, nuclear plants, and trains, that subject is called NDE 4.0, non-destructive evaluation in the fourth industrial revolution. And that's the topic today. The transformation from third revolution, 3.0 to 4.0, does not happen overnight. It's not a switch that you can turn on. It's a process. It's a journey. So what me and my partner, Johannes, started 3 years ago, I'm sharing that research with you today, and we call it Let the Journey Begin, which means we have not been thinking about it up until now. Now is the time to start doing something in that direction. Okay, I think I've already mentioned up to you as to how my life started. The most important thing on this chart is that I have failed many times in my life. All the publications, research, books, they all look good, but one must own up to that when you innovate, you will fail. And failure is a part of the learning process as we develop ourselves and technologies. I think I've mentioned all of this before, so I'll just skip that part. My interest, like I mentioned, why, what, how, and I'm now applying it to NDE subject, and I also focus on human side of it. Today's talk will have 4 items. I will give you a little bit introduction about the 4.0. Then I'll talk about why we need to put Industry 4.0 into inspection systems. Then we'll talk about what technologies go into making it happen. And then I'll close with how do we actually make it happen? So all 3 things: why, what, and how. I think you have seen either this type of chart or something similar many times if you know what is Industry 4.0. First one was steam, second one was electricity, third is computers, and the fourth is combination of physical reality and numerical and cyber systems. It's digital, physical together. In the second revolution, we became masters of the physical world. We learned how to deal with material. We learned how to process metal, non-metal, plastics, and everything to make products. In the third revolution, we became masters of the digital world, the data, the computers, processing, visualization, communication. Everything went from what used to be physical into the digital form. Now, we are at a point where we want to become masters of digital and physical world. Yesterday, I gave an example of a driverless car. A driverless car is the most beautiful, simplest example to understand Industry 4.0. The computers in the car, the digital world in the car fully understands the physical reality outside the car. It knows the traffic, it knows the road signs, it knows what is moving. The computer on the car can process that information in real time, very fast, and take physical action of driving the car, accelerating, slowing down, taking turns, avoiding accidents. The entire system is what differentiates Industry 4 from 3. It's the computer understanding the physical world, predicting what will happen in the next few minutes, next few hours, and converting that process into a physical action again to achieve a certain objective. That's what is Industry 4.0. So often, you come across people who will say, oh, I have been simulating for 25 years. We've been doing computers for 30 years. I've been doing this Industry 4.0 since 1990. Well, they just told you they don't know what 4.0 means. They don't understand the difference between cyber physical systems and digital systems. So the first takeaway in today's lecture is the thing that differentiates the fourth revolution from the third revolution is the loop that closes back from physical world to the computer world, back to the physical world, into the computer world, continuous moving loop that can control the reality. That is what defines fourth revolution. Is this loop, is the connectivity, is the flow. If somebody talks to you about Industry 5 today, now even European Union has given a definition. That definition does not do anything more than what is already happening in Industry 4.0. I will say they're either doing research on the topic or they're doing marketing of what they want to sell. We really don't know yet what Industry 5.0 will really look like. So I do not buy into any definition of Industry 5.0 as of now. And if you hear something, be careful. If it's research from a university, good, look at it. Otherwise, it could be a marketing ploy and somebody saying, I know more than you do. You calling it 4? I have what is called 5. So that's a no-no for me. So this is what I just explained. The 4.0 is the closing the loop from physical to digital world. And in this, what is happening is, at least in our domain, in the inspection domain, in the field, we already have significant amount of physical reality. We are continuously improving. The focus is more around the digital piece of it. How many technologies are there? When I started looking at it a few years ago, we had 5, then it became 7, then it became 10, 12. Today we talk 17. If I come here next year, it may be 21. The point is, the number of technologies that are becoming a part of Industry 4.0 is continuously evolving, is continuously changing. Okay. Now, let's talk about the NDE 4.0. I want to get into the revolutions in the inspection system. This is another important thing. Whenever we talk about 2, 3, 4, any numbers like that, revolutions mean something has changed significantly. Your business model, your lifestyle has changed significantly, right? Phones, going from the previous generation of phone to the smartphone is a revolution. When I grew up as a child, at your age, I did not even have a phone at home. And the waiting period to get a landline in the house was about 3 years. You fill up a form with the government, and 3 years later, they give you one phone. And phone was attached with the house. So they will come and mount it on the wall, and they control it. Now, the phone is not attached with the house, but is attached to your hip. And that is a revolution, because that changed the lifestyle. So just like industrial revolutions we talk about because of steam, electricity, computers, and now computer physical together, in the domain of inspections, we have had revolutions. And they were different than steam and electricity. It's not about power. You see, inspection is about looking at something and making a judgment whether it is safe to use or not. So the revolutions in inspection have been different than revolutions in industry. Long ago, 300 years ago, the inspections were all using human senses. Can I see it? Is this broken? We still do that at home, right? It's visual, it's hearing. Something is cracking, it makes sound, you hear and you say, oh, this is breaking, right? Right? It's human senses. We touch, we feel, oh, this is getting rough, this is getting wet. That was from prehistoric times, humans have been doing non-destructive inspection, non-destructive evaluation through the 5 basic senses. Then we developed techniques which would amplify or magnify surface defects, and you still use your senses. You know, stethoscope is same thing as ear, it just amplifies a very small signal. Looking at something through magnifying glass. Naked eye cannot see, I use an instrument, I look at it. It's still visual inspection. So this first revolution really was not a revolution in terms of how you see, but more in terms of trying to have a process to see something consistently. The initial trains were about, you must check this visually every 2 months, every 6 months, and record it, and compare today's record with the previous record, which we don't do, right? At home, if something is breaking, you don't make a note of, oh, this bottle is making noise yesterday, let me write it down so that next week I can check again to see whether it's broken or not. We don't. Right? That's because it's not, it's the primitive way of doing things. But NDE 1 was around still using human senses, finding a way to magnify that, but also making a record, making a note in the book. Then came the next major revolution, be able to see through the system, be able to see behind the wall, taking an X-ray. X-ray now allows you to see inside, which a normal human eye or ear cannot. Okay? So that was a revolution. We defined that as NDE2. Then came digital. So you have X-ray, but you do a digital X-ray. So instead of a physical film, I have an image. The benefit is I can transmit, I can email it, I can record, I can have 3 images, do the comparison. All of the benefits of computers of a digital image came in. So that was a revolution, the third revolution. Now, when we talk about fourth, we actually put intelligence into the inspection. We put intelligence in a manner where the data can be integrated from multiple sources. Data can be integrated from multiple sources to see things which were otherwise not possible, even with the digital world. Bringing in technologies like artificial intelligence, which allow you to separate the signal from the noise, even when the signal is below the noise threshold. You know, if your noise is at a certain level, the signal has to be above the noise to see it, because that's how humans' eye and ear interprets. But AI could look at it in multiple parameters and can find a signal which may be below the noise, but is amplified on a different dimension. Artificial intelligence can see that when trained properly. So that's what I call as where the next revolution in inspection is going. It's like with experience, what happens, you know, when grandfather says something is about to happen. When mother is watching the child play in the house and is able to see child is about to fall off the bed, how does the mother know? It's the sixth sense, right? And the sixth sense comes with experience. And what is that experience? How does that experience become a part of the computer today? This is what we call machine learning, the artificial intelligence. So I can put artificial intelligence into inspections, and I can develop sixth sense for the computer. The inspection equipment can now have the sixth sense. That would be revolutionary when it comes to inspection, because now you have inspection equipment that you take and inspect something. It's not cracked yet, but it will crack in the next year or so. An experienced person can feel it, but if I'm able to translate that into artificial intelligence, machine can also predict that. That would be NDE 4.0. So that was my outline of what the fourth revolution in inspection is. We are now going in the inspection world from being able to see behind the surface, being able to handle it digitally, and now even able to see ahead in time that it will crack in the next 6 months, right? And where will it crack? So we are adding a new dimension to our understanding, and that's why we call it a revolution. Why do we want to do this? Let's talk about why. How many of you have seen this picture before? How many of you have seen this picture before? Okay, a few of you. This happened in 1988. Actually, my career on the topic started after that accident, because that generated so much money and so much interest in the industry. So many universities started working on it. Just imagine you were in that box at 30,000 feet, 10,000 meters above the ground, and it becomes a convertible. I like convertible car. I don't like convertible airplane. So this pilot was very good. He brought the airplane back to ground. I think there was only one flight attendant who was serving food at that time when the roof ripped up and she got thrown out. Everybody else who was wearing seatbelt stayed in the plane and survived. Some more recent crashes happened. We talked about it briefly when we were waiting for the computer to come up. Okay. So we do inspections because they are critical to safety. That is why we do. There's another reason we want to have inspections done automatically. Here is a coal boiler where the inspector has to go in to a very hazardous environment to do the inspection. But today we have drones. So we can actually save the inspector from having to go in by sending a drone that does the inspection. Okay? So there is value in automating the inspection system. It takes, it assures safety for the passengers who are in the airplane. It assures safety for the users, travelers in the train, for the users living in the neighborhood of a nuclear plant. But it also helps us with safety of the inspectors. All the people who are developing NDT equipment and companies that operate these systems, they want to make money. They want to be in business. They want to be profitable. So they look at how can we also pursue it so that it makes business sense. And one of the things that the fourth revolution does is it brings you both safety as well as economic value. The economic value comes from being able to inspect only when you need to inspect, to change parts only when you need to change, and to be able to predict the future performance. If you can predict how this machine will behave in the next 6 months, 12 months, 2 years, you can optimize its use. You can utilize it to the maximum. So that's why we pursue this revolution. It is actually taking you from, it's a very interesting thing, from a planned maintenance to an adaptive maintenance. In the history of safety, long ago, it was all intuitive. It's risky, don't sit under a tree about to break. Then engineers came up with the concept factor of safety around Industrie 1.0. When it came to 2, we started looking at how do we prevent it? You know, the concept of safe life and fail safe so that you avoid failures unintended. We had gone based on the computers to what we call as a predictive maintenance. Use the computer simulation to predict what to maintain when. But it was still just like Industry 3.0, mass production, mass application. What 4.0 can do for us is it can take us from predictive maintenance to what we call as prescriptive handling. You know, just think about it. We all, when we work with doctors, doctors treat us as individuals. You never have doctors saying, well, there are vaccines that you do where everybody has to participate. But otherwise, we all get our own prescription from the doctor. This is my health problem for which medicine will I take? It's for me. It's not for everybody. Right? Same way, each airplane, each train, each nuclear power plant, you can have a prescription for that particular asset as to how to assure its safety. Up until now, it's about, okay, Airbus 320, it will be maintained like this, which means all Airbus 320 must follow the same maintenance plan. But going into 4.0, each of those airplanes can have a prescriptive handling program. So when you start prescribing specifically for each asset, you really optimize the cost. That's the value of 4.0. In any particular thing, you normally have to deal with quality, cost, schedule. So similar things, you know, faster, cheaper, better. You can normally choose only 2 out of 3. And the third one is an outcome. But when you are going through a revolution, that's the only time, which means the next 5 years or so is the only time you can get all 3. Afterwards, when the revolution is behind us and we get into small changes, you can only control 2. The third one is not in your control. But while going through the revolution, it is possible to control all 3. That is why we need to focus on it now, is to be able to get economic value, safety, and speed, all 3 together. Faster, cheaper, better, all of them together. I'll skip that piece for a moment. All right. And here, have you heard of the concept probability of detection? No, then I think I can skip that because it's.
Yes, you can speak about that.
You want me to skip?
Yes, I will understand.
Okay, they will understand. All right. So, does it ever happen that you go to the kitchen and you open the drawer and you cannot see the pizza cutter? And then you call your mom or somebody else and say, "Mom, where is the pizza cutter?" And mom says, "It's there in the drawer." And you still can't see it, and she comes and opens the drawer and the pizza cutter is over there. You just didn't see it. That's the concept of probability of detection. Something is there, but you're not able to see it. Right? Can I see a black chalk here? No, because there is none. Can I see a red chalk here? No. Can I see a pink one? Oh yeah, it was hidden here. There it is. Whenever something is damaged, if there's a crack in a structure and you're using an instrument to find it, there's a probability that you can see it. Okay? And typically that curve looks like this. Very small cracks, you really can't find. They did not even exist. Even a crack size of 0, there's a small probability. What does it mean? False call. It wasn't there. A 0 crack size means crack was not there and you still found it. So you've got a signal and you thought it is cracked, but it was not. But then at some point, it becomes visible. So one of the concepts we use in POD is this kind of a curve, and to see what is the crack size that you can detect with 90% probability, 0.9. And you normally design your inspection program based on probability of detection of 90%. You say, okay, so if somebody finds a crack, then you roughly know, well, it's probably larger than this. If the inspector can quantify, great. If the inspector cannot quantify, at least you know what's the minimum that exists. Now, people who make the equipment, the inspection equipment, they talk in terms of capability. They will try to tell you what's the smallest crack the system can detect. But in real life, if I work for Air France and I have to manage my fleet of Airbus. Good, you're telling me I can find a small crack. Question I have is, what's the largest I can find reliably? I want to know the largest I can miss, because that is what impacts my safety. Not the smallest you can find, but the largest you can miss. So we do what is called probability of detection studies, where you get all of the inspectors, the equipment, and the component, and you look for the largest crack that people can miss. And usually that curve looks like this. It tends to go in the other direction. So this is, the red curve is what me as an Air France operator has to use. The green curve is the one that somebody who built the test equipment tells me I should use, but I can't use it. I have to use the red one. What Industry 4.0 can do is it can compensate for human factors and push the red curve back to green curve. In fact, if the machine learns over a period of time, it can even do better than green curve. Okay. It can go up to blue curve, and actually it can push the green further on the lower crack sizes as well. And that's what I was calling sixth sense. We are able to see things that are yet to come, that are yet to appear. That's the value of 4.0 in inspection systems. That is why we need to pursue digital, physical combination in the inspection systems. Safety and economic value both. Okay. Anybody need a 2-minute break? Stretch yourself. We know why we are doing it, right? Any questions so far on the why of fourth revolution, the introduction of NDE 4.0 and why we should pursue it? Yes.
We still need human intervention with seeing like cracks and stuff like that.
Yes, you would still need human intervention. As of now, yes. So human in the loop, it's digital, physical, but human in the loop. Do not completely eliminate it out for 2 reasons. 1, compliance, regulation. Okay. Yesterday we were talking about EU regulations around automation. It has to be traceable back to humans. Systems are still to be trained by humans. The artificial intelligence, machine learning, I do not want the machine to learn from another machine that did not exist up until now. I want humans to train it. And I want every decision that a machine takes, I want to be able to trace it back to some responsible trained human. Good question. Good. Shall we continue? Yes.
Yes, I have a question. The more we go to a smart technology, the more we move away from circular economy. Because when you make computers, when you make alloys, it's really complicated to recycle it. Moreover, smart technologies require a lot of electricity to work, a lot of data, and in the world, 65% of the electricity is made with fossil fuels. You talked previously about climate change. You say that climate change is real, it's a real threat for humanity. But don't you think that if we try to do some green growth, we'll go in the world. We have some problem of resources like copper, and we have just some problem with energy, because what makes growth possible in the past decade is fossil fuels. But if we want to turn from fossil fuels to renewable energies or nuclear energy, do you think that we will be able to have the same transformation of energy that made the world now possible?
So renewable energy, the challenge with renewable energy is actually not technology, it's economy. We have enough technology to generate enough renewable power around the world. It's just that the fossil fuel plants have been there for a long time. All the investment is paid off. It's the cost problem, right? And that is why government all over the world gives incentive to go with renewable energy, right? So we will go in that direction, there is no question. Going more digital, does that consume more power? The answer is yes. Can that power come from renewable sources? Yes. Does going digital hurt the circular economy? To some extent, yes. a lot of chips that we make, they're not reusable, they're not recyclable. That is a problem. Right? So we have to find alternate ways to compensate for that. Can we add more trees? Can we control the use of meat? Even meat is an important element that's hurting the ecological balance, right? Can we be responsible about waste? Can we be responsible about materials? Okay, I can't do much with electronics, but the plastic around electronics for my device, I can do something about that. I can have a bioplastic. The most important thing is, are we aware and are we consciously compensating for it? Actually, one of the use cases of Industrie 4.0, and particularly this thing that we talk about, the digital twin, if you can digitally track every piece of asset, you can use that asset for as long as you like until it is really used up. And even at that point, you know enough about that asset to repurpose it for something else. You know, today, when an airplane retires, we don't know what to do with it because we don't have the history of how it was used. But if I knew that, I can actually repurpose a lot of parts. So I may not be able to completely reuse the product I built, but I can use it for as long as possible, which means I'm still working to reduce the waste for the planet. Okay? I'm so glad to hear that question from you. Okay? It's this questioning which is more important because we will find an answer to these questions.
Yesterday.
Thank you. What?
Yesterday, nobody thought. Nobody failed.
I'm sorry, I missed it.
Yesterday, nobody failed.
Oh, okay. He wasn't ready. That's okay.
Human experience.
All right, let's get to the what part of it. Okay. So within the inspection world, the what includes things like robotic inspections, all sorts of robots. Back to his question, can we recycle those robots? Probably not. And am I saving the human today? Yes. And can I do something else? Can I repurpose them for something else later? Yes. Should I be designing these with materials that I can recycle? Yes. Should I be designing these with an intent that at the end of the life, I can break it open, not put it in the junk, break it open, reuse whatever parts I can, recycle whatever parts I can. See, the circular economy is, the circular economy really starts from the very first moment when you conceive the product. If you did not conceive it correctly, you may not be able to circle it back. Artificial intelligence is another big component of Industry 4.0 of NDE. Taking pictures and having AI recognize faults in that picture, identifying faults as to what could be corroded, what could be cracked, is an important what in it. Augmented reality, that's another big one. Being able to see, an inspector can see the crack, wants to show it to the manager, is unable to show, but augmented reality can help that communication. It can help communicate what I see with my mentor, with my boss somewhere else, so that I can get input in terms of making the decision, making the judgment. Plus, another big component of augmented reality is around training of inspectors. Giving somebody an instruction to go inspect just in time, to go inspect what, when, where, can be done through augmented reality, which means I don't need somebody with 20 years of experience. I can use augmented reality and artificial intelligence and give it to someone who may have only 5 years of experience and still be able to make a judgment, a decision with the same level of competency, with the same level of reliability, because I can use these technologies. And drones, I don't know if you've seen this picture or not, but this is a very beautiful piece of device. It's a drone which has got a full cage around it. So it is completely protected. I can send it inside a tunnel. I can send it inside a boiler. It can bounce back here and there. It can hit the walls. It can still do the job and come back. I don't have to worry about it as much. I think I have a video if that works. So this is now inspecting inside the confined space. Does anybody know how to turn this light off? It'll get better. You can see the screen better if we can turn those lights off. Serge, can we turn the light off? It'll be clearer. Sorry, it took me 40 minutes to realize that. Okay. All right, here's an example. Here's another example of where one flying machine is inspecting another flying machine. Just imagine drone inspecting an airplane. The younger brother checking out on the bigger brother. How are you doing? So these are all part of NDE 4.0. I can go a lot into the detail of, there is a debate, and Serge is a part of that. 6 or 10 of us around the world from different countries are really trying to put box around what is NDE 4.0. We think about it, you can bring Industry 4.0 to NDE, or you can take NDE to Industry 4.0. But let's say you are using traditional inspection methods to inspect advanced manufacturing. That is applying inspections to Industry 4.0, to smart factory. And there's an example of that. This is actually not NDE 4.0. Okay? Where we are at a point where we say, trying to use traditional inspection methods for, let's say, additive manufacturing is not NDE 4.0. Okay. Here is the inspection system from 3.0 generation, but being used on a fully automated part, 3D printed part. This does not qualify to be NDE 4. But if you bring digital technologies from Industry 4.0 into NDE, it does qualify to be NDE 4.0. The example is this. There's a truck with remote sensors in it, which is inspecting a bridge that is 100-year-old. The bridge was built during Industry 2.0 era. Today, we are inspecting it with advanced technologies. That is NDE 4.0. But the real game is when you do both together. When you have a true digital transformation, that's like the purest form of NDE 4.0. An example could be a smart factory, and it has a fully automated inspection in it. Now back to your point, is the human out? Human is out of the loop, but it is on the loop, not in the loop, but on the loop, which means human knows, human is watching the loop go physical, digital, physical, digital. Human is outside the loop. That is the true digital transformation. That's the purest form of NDE 4.0. Many of us have started defining it so that others can follow it. We have given two definitions. There's a short definition and there's a long definition. The short definition is a mutual convergence of NDE and industry technologies for social, safety, economic, and reliability. So, the three things that we talked about: faster, cheaper, better. It's like that: safer, cheaper, and dependable, right? So if you bring digital technology and physical inspection methods together for a purpose, it's NDE 4.0. The full definition, which some people are uncomfortable, as of now, the proposed definition is, it's the cyber-physical NDE, which comes out of confluence of Industrie 4.0 digital technologies and the physical inspection methods and business models. Business models mean how you take it to a company, how you generate revenue, how you handle it, in addition to the technology piece of it. Two, for a purpose, we have to define that. Enhance inspection performance, integrity, decision-making for safety, sustainability. And the final piece is how you take the data back to the design. So there's a lot in here. If you're overwhelmed, I can understand, because even experts on this topic struggle with how do I condense this without losing the meaning. There is so much in here. We want to define why, what, and how, all three in one definition. So I always say, okay, here is a real definition which gives you a complete explanation, but then this is the shorter one, if you like to use it. Either one of them would work. So that's the what piece of it. The kind of a scenario it can create for us going forward is like a smart depot, whether you think of it as an airplane or a train depot, where the depot starts preparing for an aircraft to come in even before the aircraft comes in. The augmented reality tells the inspector, walks you through, you put on your goggles, it walks you through, go there, touch this, inspect this, report this. The scheduling system manages the flow of spare parts and the repair activities. The workflow has become smarter. It adapts to somebody called in sick, not able to be there if there is still human in the loop. The components, each component has a digital twin and has a digital tag and is digitally tracking its history and usage. Robots could be performing the inspections. Robots and humans could be collaborating to perform the inspections. Artificial intelligence does the analysis for you. Something had to be changed on the spot. You use a 3D printer to create a spare part quickly and replace it. You don't have to wait, order it from the Airbus, and it comes in 3 months. No, you print your spare part and you install it, and you let the airplane go back to service. So that's what a smart depot, maintenance depot could look like in the near future. This is not my vision. This came from Deloitte, another consulting firm, and I believe this will happen because most of the elements individually are now possible. Each of the technology has proven itself to do the job. The business model is still not there. That's why adding business model to the definition of NDE 4.0 is an important step. Because it's a business model that will push managers, owners of the companies, to put these technologies together, to train the leadership and the staff to work with the technology, be able to manage the data, and be able to take additional decisions for prescriptive maintenance. That's why I believe this will happen very soon. The way I look at it is, my vision is over here, that if there's an airplane out there, I create a digital twin for the airplane, a complete digital twin where I can capture the data, the history, the usage of every part. I use 5G or maybe 6G whenever that comes by 2030. I capture the relevant data, not big data. I capture the relevant data all the way from the manufacturing time to in-service usage, bring it in and create an asset knowledge base, which helps me take the decisions. I use the same technologies we just talked about, augmented reality, simulation, predicting the damage progression, and play what-if scenarios just like a driverless car does, so that I can prescribe how to handle this particular asset. You remember I mentioned prescriptive maintenance as against predictive or preventive maintenance. Okay? I can now prescribe for this particular asset how to handle it. And I'm not talking about maintenance. I'm talking about handling, because handling is more than maintenance. It's about also how you use it. I can put restrictions. I can put limitations. Don't fly more than 11 hours at a stretch. Okay, don't carry more than this load. Just reduce the max load. I can put certain restrictions. How you handle it so that you can avoid failure. Human is still in the loop. The biggest value over here is that NDT is always viewed as a cost center. Managers don't want it. They think inspection is a waste of time and money. They do not like it. The business operators do not like inspection. But the way we are looking at it now is the inspection data has value. So even if I take the airplane or train out of service for a few hours to do the inspection, the data I generate creates value. So I can go from inspection being a cost center to inspection being a value creation. Okay, that's a big mindset shift. And Johannes and I work very hard on this particular messaging, that it's taking NDE, it's regenerating, it's rebuilding the respect for the profession, which is very important. But this requires that we need to look at it as an ecosystem. Okay. The real value will come when the data can be shared across multiple entities. So it's another piece of what. What is the data? Where is it coming from? And who is sharing it? Because, you know, there's a asset OEM is like the Airbus. They built it. Owner operator is the Air France that's operating it. Inspector could be me, who's inspecting the airplane every day. And NDE OEM could be Serge, who built this new equipment that does the inspection. So we are all important players. The people who build the asset, people who build the equipment, people who do the inspections, people who operate it all together. And then there are others. There are universities, there are suppliers, there are training centers. They're all a part of what we call as inspection ecosystem. The big difference in going from Industry 3 to Industry 4 is this whole perspective that we need to think about larger than the boundaries of the organization. If we limit ourselves to the company we belong, we will get some benefit from the fourth revolution, but not as much as we would like to. To get full benefit, we need to look at it as an ecosystem, where data is the environment. So we're bringing in the fifth thing in here as a stakeholder, which is the digital twin. Okay, I've got 5-minute warning here. I'm going to skip a couple of things so that I don't confuse it. Let's just go to the how piece of it. This needs a lot of explanation. I'll skip that. Oops, I can't. Oh, okay, I can't see that. I just want to skip a few things.
Huh?
Yeah, skip that one. Let's go. Let's skip that. Let's skip that. Actually, you know, there's a lot of discussions here. It's okay. We don't have to do the how piece of it. If I have 5 minutes, I would rather have conversation.
Yeah.
Okay.
Sorry, Ripi.
No, I understand.
It's due to the technical problem. I apologize.
Okay, no problem. So, you know, the how piece of it is around innovation, how you go from idea. If you've understood the why and what, it's actually good at this stage, because how is very important for organizations or to make it happen, right? So, you know, maybe 5 years from now when you become managers in places and you actually have to do it, then you can learn how to do it. Or I can share a paper with you, you know, we can share this with them, a PDF, so we can get there. But the important thing over here is you look at it as an ecosystem, everybody together, work with data as an environment and work together to make it happen. It's a journey. It will not happen overnight. It takes a few years. You have to deal with a lot of uncertainty and ambiguity. But in total, it makes sense. I always used to say, doing things together is better. Okay? But now I say, with the NDE 4.0, I say that together is the only way to do it. Because otherwise, it's like the moment data becomes environment, it's like air we breathe. It's like water we live on. It's like the infrastructure. You can't be on your own. You have to be a part of a system to work at this together. And we have been doing these things together for a while. You know, we are all a part of an international sort of, we started off as an ambassadors program 2 years ago. Now it's a part of ICNDT, special interest group. So we are actually doing this together through conferences and stuff. Serge is here. We work together a lot on this one. Here are the things that the international community is doing. They're looking at it from all three perspectives, technical, process, as well as human. With that, I will close my talk, take some questions. Yes.
You talked a little bit about machine learning. You talked about machine learning and said that you weren't really interested in it because human learning and human, humans are actually not good. But I've seen that in the recent years. I felt like machine learning was more efficient. I don't really understand why you don't want to do it.
Okay, that's not what I meant. Machine learning, I want machine learning in there, but I want these machines to learn from humans who are qualified.
But if you look, for example, my only example is chess, but a human was bit by a computer who was taught chess by another computer. So I feel like if we use some abilities that perhaps humans have never seen before, especially with new technologies where we don't have as much experience, we might be more efficient while using
So the humans which taught the machine to play chess, those humans knew how to play chess.
Well, the computer knew the basic rules.
Right. But those rules were built by people who knew how to play chess.
Yes, but there is only a certain set of rules that can be given.
Correct.
Whilst with experience and with machine learning, we might know more.
Correct. But where did it start from? If somebody who did not know chess, and you ask them to write a machine learning algorithm to play chess or to train the chess, it won't go that far, right? It has to start, the starting place has to be correct, right? So with chess, again, with chess, the rules are all black and white. You know what you can do. You can do this, you can do this, and you get there, right? There are finite number of discrete elements that you can do. When it comes to inspection, whether it is crack, corrosion, where is it, how far it is, it's not programmed by the machine 5 things. The way to program that is to have experienced inspectors take the image and make it deceive, right? Just go to a hospital scenario, X-rays, right? I don't know how to read X-rays. If I start training machine learning algorithm based on everybody's X-ray over here and say which one is broken, which one is not broken, I will completely mistrain it, right? For me to train an X-ray machine to predict a fracture in a human bone, I must know how to read an X-ray and spot a cracked bone and then tell the machine, okay, this is an X-ray, it is cracked. This is an X-ray, there is no crack in the bone here, right? And if I don't know how to read X-rays, I will train it incorrectly. I will just randomly say, these are broken, these are not broken, and then the machine will be confused. In fact, it so happened that there is a beautiful story just around this, where trained doctors gave over 150 X-ray, digital X-ray films saying, this is a healthy bone, and this is a broken bone, right? And the machine learned completely incorrectly, in spite of being trained by good doctors. What happened over there was that the X-ray films had the hospital name on the film underneath, okay? And the machine started correlating fractures with the hospital name. And next time when an X-ray came, based on the hospital name, the machine was identifying whether there's a crack or not, which was completely wrong. So because there is, in chess, there are finite things, but when it comes to detecting defects and in an image like that, even with smart humans, we trained it incorrectly. And if you notice, some similar stories are happening with all sorts of airport security. Amazon trying to hire employees through machine learning and then getting sued for discrimination. So in spite of all of that, we still have a problem. And that is why traceability back to humans is very important when there's a judgment involved.
Thank you very much, Ripi. You can this. Okay, thank you very much, Ripi. It was a real pleasure. You can discuss during the break. You can discuss during the break, and there will be a closing session at noon, at 12:25, just after your last lecture. You can come here, and we will have a closing session with Roger Serra, which is the director of the GSI department. And we will finally close this, and I will make a short presentation. You can discuss with Ripi just after your lecture. Okay, thank you.
So on this particular topic of NDE 4.0, we've just published a book, the one in the center, and I want to give a copy to Serge.
Again.
You want to open it?
Oh, this one?
Yeah, open it.
I should check.
No. Here, 1 second. Now that you're here. There's a picture, bro? Thank you.
Thank you, Ripi.
Welcome.
So we will make a break for the students and the researchers, and then we will come back with the lecture of Émilie Jousset, which is an INSA alumni coming from INSA Strasbourg. And have a nice day and see you soon. Again.
I'm sorry, I had to go a little slow because I was not people were not engaged. But I think the content
Exactly. Perfect. That was perfect. No problem.
I think it was better to skip the last section rather than breeze through it. Okay.
Oui, donc il y a les livres qui sont là, donc du coup maintenant j'en ai deux à moi, parce que si ça va, ces deux-là, c'est la bibliothèque de l'INSA que j'ai acheté. Et ceux-là, c'est la bibliothèque de l'université. Ils sont en français, ils viennent de sortir. Donc si vous les traduisez, you can make an arrangement with Ripi, and I can translate it in French, and good luck. Okay, so you can make, you have to... Ils viennent de sortir.
Pour diffuser, c'est mieux du coup de le faire sur le PC qui est ici.
Si tu as ton PPTX, ça ira beaucoup mieux. En plus,
Par contre, j'ai pas de clé USB pour le
ouais, bah, hop.
Yes. That will happen. We are talking about the digital twin for the inspection equipment, which will practice and use it, right? Which will self-calibrate as the calibration is wrong. It knows it should self-declare that I'm not doing an inspection anymore.
Parce que j'ai eu un problème ce matin. Mon Zoom, j'ai dû réinstaller mon Zoom. Je ne sais pas ce qui s'est passé hier.
Est-ce qu'on a bien deux écrans? C'est-à-dire que les deux là, on n'est pas obligé de les mettre les mêmes, comme ça je peux avoir mon mode présentateur.
Je vais essayer. Je vais essayer. Donc là, je quitte la réunion ici. Ensuite, ici. Je quitte aussi. Là où je sors ici. Je quitte.